Five, 4, 3, and welcome to
calculus.
Pre-calculus again. Here we are in pre-calculus, and we are on a very special Stephanie Rawson lesson today. Steve Peck. And on this very special lesson, we have a couple of things we're going to do today. First of all, you'll notice the subtitle up there. Today we have what?
Anti-derivatives.
All right, we have tidbits 1.
Which is integration.
Okay. All right, I have to redo this. All right, we have tidbits 1, which means today we will get a special copy of the sample test, so you know what to expect. And also, you'll notice this is a pretty short section. We just basically do the second derivative test and the thing we do today and tomorrow. Okay. Also, this is going to be your first ever antiderivative today.
And integration.
How about that? All right, so it's very special. I remember the day that you did your first derivative ever. Yeah, your parents should have been here taking pictures. Your first step, your first word, your first derivative.
That's the first day I missed school.
All right, we got you on it. So today, again, your parents should be here taking pictures. Your first antiderivative of your whole life. This is a major deal right here. Okay?
My mom will probably laugh.
All right,
Let's learn.
let's do it.
Here's common for us.
I don't know this. Okay, now let's discuss, because we're going to find out today. Remember all those nice problems we do where they're all handcrafted and like you can factor it, it's perfect. Okay, well, what does Mr. Wade do? I take two factors together and FOIL them, and then if it's the double derivative, I'll just anti-differentiate twice to get back to the function. We'll see how to do that today. Okay, how to handcraft your own problem. All right, you go right back.
Yes.
Well, I did in high school, but I was different.
It was different.
Anyways, so
Yeah, you got a perfect square.
for a
So did
square,
I.
yes, for a square.
So did I.
Square. Oh, did you? Yes. Okay, that's good. All right. Now, anyway, so we're going to figure out how. If I give you the derivative, how do you get back to the original function? Because that's important. So we have this. All right. First of all, I'm sure we all know the derivative of 2x cubed.
6x squared.
6x squared, that's the easy one. By this point in the year, everybody knows that. You can do it in your sleep, right? Okay. But, look on the side there. Leave the 1 and 2. Okay? Just kind of, I should have told you that, sorry. Write that down. Okay, the derivative is 6x squared. We know that, but over here I want you to explain it. Like, how does it happen? Why is that true? Okay? Can you explain what happened?
Bring down 3.
What is the very first thing we did? How did we get the 6?
Bring down.
Power rule. Okay? It's a power rule, right? Very good. Good memory.
Okay.
It's kind of a chain rule because it is times what? Times 1, but really we just call it the power rule. So, the coefficient gets multiplied by the what? By the coefficient. Okay? So,
Close.
pay attention. All right, now, write down coefficient times, and by the way, would you say we're multiplying by the old power or the new power when we do this? Yeah, it's kind of the original power, it's not the new one that changes, right? So you multiply the old power, or old exponent, times the coefficient, okay? Easy. And then what's the very next thing you do? You do the exponent minus 1. And that's just the simplest derivative you can do, right? Okay. So what we're going to do is see if we can figure out how to do the antiderivative. Right. Okay, now before we do that though, side note, what is the derivative of y equals 2x cubed plus 55?
6x squared.
It's also the same thing. Now that's interesting. Huh. So what Mr. Wade's going to do is, I'm going to say, here's the derivative. What did it come from? The only thing we don't know is if there was a number or constant there, because it would disappear to you in the derivative, right? So you'll know how to go backwards, but you won't know what the plus constant will be, because it could be anything. Can you see that? Isn't the derivative of 2x cubed times, or let's say 2x cubed plus 1,000,000. Yeah, 2x cubed plus 1,000,000, isn't it still the same? Okay, yeah, you don't know the constant is, okay? So eventually now, when we get into calculus, you'll get hints to try to find out what the constant is, but you don't have to worry about that yet. Okay? So here's what we'll do. For b, f prime of x equals 6x squared. Pretend like you don't know what this means. All right? Gee, where did that come from? I don't know. All right, so what I want you to do is I want you to think about going backwards and trying to get the original function. Okay? So what we're saying is, whose derivative is 6x squared? And here's another way to phrase that question. All right? Which function's slope is measured by 6x squared? Isn't the first derivative slope?
Yep.
So what you're saying is, I've got this slope, and apparently the slope to the mystery function is a parabola. I wonder what the original function is. Do you notice that the derivative of a snake is a parabola? See that? So the antiderivative of a parabola should go back to a snake again, right? Of course. All right, now, let's do this on the side here. Okay? A little illustration. Label this as f prime. What if you were doing a first derivative test? What if you were on the derivative and you had 6x squared? Are there any special places there that we should put on this graph?
Yeah.
Okay? 0 would make this neutral, so 0 is a 1.
Okay.
Critical number, very good. And by the way, of course, there's no D and E about 6x squared, right? Because no place this doesn't exist. So you would put down 0, and then you would pick some sample points. Anything below 0 that you plug in and square, it's going to be positive. Anything that you plug in that's above 0 and you square, oh, so this is always positive except for 0. So if you think about these derivatives as first derivative tests, you can kind of think about the original function. Because the derivative test tells you where the original function that we don't know right now is what? What is plus 1?
Increasing.
Okay, that means the original f is increasing, and the original f is increasing. And now think about what function would always be increasing. Would the snake fit that? Increase, increase. And you got a little false reading there. You know why you get that false reading? Can you picture the tangent lines getting more and more shallow? And for one moment, it actually goes horizontal. You have a 0 slope. That's why that happens. But then it keeps going up after that. Okay? So that's why that triggers that false neutral there. True, the derivative or slope was 0 actually for one moment, but then it kept going up. Okay? So 0 is the inflection point, exactly. Yep. Which can be accidentally discovered on the first derivative test, but not always. But the second derivative guarantees that you find all the inflection points. Okay? So we just accidentally found the inflection point. Okay? All right, so based off that now, let's talk about it. All right, we are going to go backwards because we're doing an antiderivative, but not just backwards. Backwards and something opposite. All right, opposite. And when we go backwards and opposite, let's see what happens. Okay, think you're number 1 and 2 right here. If you were to go backwards and opposite, step 2 would become step 1. Although it's opposite. So the first step in an antiderivative is to do exponent plus 1. Okay? So you do that first. And the second step would be the opposite of this first step. It would be the coefficient divided by, and the opposite of old is new exponent. In other words, the one with the plus 1 on it already. That's how you do an antiderivative. Okay? How about that? Interesting. All right. So it says here, what is the antiderivative of 6x squared? All right. What's the first thing you do to 6x squared according to these rules right here?
Add an extra.
Add 1 to the power, which would become
6x.
6x cubed. I think we should go to 10 bells instead of 5.
Yeah.
You guys.
Let's
Let's go 10. 24. Sit here and listen to it.
Right.
All right. Anyways, okay. So you get 6x cubed, right? Divided by, what do you think? Divided by the new, not the old, but the new exponent. And guess what? 6x cubed over 3 is? It actually works. How about that? Nice. There it is. Okay. Now, that is the antiderivative. But we mentioned something earlier. What about the constant? Remember the constant? Okay. There could have been, hold on. There could have been a number right there, plus or minus a number that disappeared. Okay? We don't know. When you do the antiderivative, you don't worry about the constant. You just strictly do the backwards rule, and that's it. So you're done.
What's the hint you get?
Now, the integration, you do worry about the constant. It's the only difference between antiderivative and integration. They're the same thing. So when we do the integration, it would also be 2x cubed
Plus C.
plus, and you can let c stand for what word?
Constant.
Okay? That is for the English word constant. Or if you really want to go old school, when they first discovered derivatives, way back in the 1600s, guess what they used instead of c?
X.
They did not.
G.
German.
The German word for constant is
Okay.
constant.
No.
But it has a k instead of a c, so they used to use plus k. So if you really want to go old school, you can use plus k instead of plus c. But usually we use plus c, so either one's fine. Okay? Plus c, plus k, whatever you want.
Plus CK?
No, not plus c. Plus c, plus c. But if you put plus k, I put it down. Here we go. Open up the door just now. Well, it's not extra wide. You can, let's say it's plus.
Please excuse the interruption. Andrew Doe, please report to the office. Thank you.
Is that a fake name, like John Doe? That's not right.
Are you going to lockdown? Yeah, are we?
It's a code name. Oh my gosh, it is a code name. I don't think it is. No, I can't. Wait, what did they tell us in the meeting the other day?
I think it's a code name.
No, they didn't. Wait.
I was
Mr.
locked
Man
in.
never uses the intercom.
There's no Andrew Doe.
Never.
I would like to.
And they're not allowed to talk during class.
Well,
I would like to.
Please tell me if you know someone named Andrew.
I think they would just, I think they said they were just gonna tell us it's a lockdown. They would tell us that.
No, just
No,
no. I would lock the door.
Yes, I wasn't paying attention.
I would lock the door just in case. That's a total. That's all. Andrew Doe is like the most like generic name, like Jane Doe, but it's a male. Like.
So it's a guy in the building.
Steve Doe? I don't think there was even a last name Doe, that's why they use it for John Doe, Jane Doe, because it's not what it
Yeah, I
is.
think you should lock the door.
Oh gosh.
I think we actually.
Oh, son, what's happening?
No, he's restarting.